Section 3.3 is about solving systems of inequalities by graphing. We've done this before, so we're going to get right into it. We'll start by graphing a boundary line for each equation. Graphing this equation, the slope is -2, which we make -2 over 1, and my y-intercept is the point 0, 4. So I'm going to go over here and start at 0, 4, and my slope is down 2 to the right 1, down 2 to the right 1. I'll graph that line. Now if you notice, I made that line a dotted line, and the reason I made it dotted is because it's a greater than without an equal to sign. That means the line is not solid, it's dotted. Second equation, the boundary will be y equals x minus 2. Slope is 1, which we make 1 over 1, and the y-intercept is the ordered pair 0, -2. So now we're going to graph that line. So that's what that line looks like. Now I should have probably done the graphing right away, but I'm going to go back and do the graphing for each one of these now, or the shading I should say. Looking at this first line, I want to try a point, and I like to try 0, 0, so I'm going to see if 0, 0 fits in the original. So plug in 0 for y, 0 for x, and we end up with 0 greater than 4, which is false. That's a false statement. So we know that 0, 0 is on the bad side for the blue, so I want to shade on the right side. Then with my second line, I'm going to try another point. I'm going to try 0, 0 again, just because I like that point. You can try any point as long as it's not on the line. So I plug in 0, 0 into the original right here. 0 is less than or equal to 0 minus 2. Is 0 less than or equal to -2? That is also false. We want to shade the true side, so I'm going to shade the bottom because 0, 0 is on the false side. So now that we have them both shaded, we want to try to find any place where those two shaded areas overlap, and that would be right here in this region here. And so I make that a darker shade. With your pencil, you just make sure that that's shaded in darker. With the use of technology here, I'll just make it purple. So my solution is this purple area. It's the only area that is overlapped or crossed by both the blue and the red area, so this dark area on the right is my solution. Here's our next example of inequalities. We'll start by graphing the boundary line of the first. So my slope is 1 over 1, and my y-intercept is at 0, 1. So here's 0, 1, and 1 rise of 1, run of 1. And because it's greater than, I'm going to do a dotted boundary line. Let's go ahead and do the shading right away. I'm going to try a point. Looks like 0, 0 is on the right side. So I try that one. I plug in 0 greater than 0 plus 1, which 0 is greater than 1. That's false. So 0, 0 is on the bad side. So I'm going to shade the upper left for this graph. So that's my first one. My second inequality is absolute value, which if you remember back in previous sections we talked about, we can rewrite as positive y is less than or equal to 3, or negative y is less than or equal to 3, because the positive distance is smaller than 3 and so is the negative. So that actually creates two equations, two more lines I'm going to graph. This one, y equals 3, and so we'll put that one up here. That is a horizontal line, and because it's less than or equal to, it's going to be a solid horizontal line. So there's the horizontal line y equals 3, and now if we plug in 0, 0, we get 0 is less than or equal to 3, which is true, which means 0, 0 is on the true side, so I'm going to shade below this line. And then the last one I want to solve is here. Negative y is less than or equal to 3. The boundary line should be equal to, and then we divide everything by -1, and so we make it y equals -3. So that line is a horizontal line down here at -3. So there you see that line. I did it in red again, and now we're going to try 0, 0 to find where the shading is. So we say -0 is less than or equal to 3. Well, that's true because there's no such thing as -0. So 0, 0 is on the good side, which means I want to shade up from that red line. So the point is my shaded region that has all three of them is below this upper red line, y equals 3, and then above the y equals -3, and it's to the left of the blue dotted line. So that purple area that's in here, that is my, all the ordered pairs in that region will satisfy both of those inequalities. For our next example, I would suggest you pause it, try it for yourself, and then come back and see what the answer is. So here's the work with the first boundary line, or the first equation. Slope is 1/2 and the y-intercept is 0, 1. So I do 0, 1 and go up 1 to the right 2, up 1 to the right 2. It's a dotted line because it's greater than, and when I plug in 0, 0, I get a false statement, which means I'm going to shade on the other side, the true side. Second boundary line is for the red one. Again, slope is 1/2, rise over run. Y-intercept is 0, -3, so I started down here, did up 1 to the right 2 each time, did a dotted line again because it's less than, and when I plugged in 0, 0, which is up here, it's false, so I shaded the other side. If you notice, neither one of these shaded regions overlap each other, so the solution to this system is no solution.